All right, so we're going to pick up in the notes talking about distance. A space shuttle maneuvers so that it may capture an already orbiting satellite that is 6,000 kilometers ahead. If the satellite is moving at 27,000 kilometers per hour and the shuttle is moving at 29,500 kilometers per hour, how long will it take the shuttle to reach the satellite? All right, so here, this type of problem, we're talking about motion. This is a motion problem. Now, I like to do all motion problems with the same mindset and the same way to think about it. And it's rate times time is equal to distance. I guess I can just say, I'll say distance. Rate, that is how fast you're going, right? Your speed. This is the rate, right? And then time. And then we know that equals distance. Most of the time I put D, right? All right, so with that said, let's think about this problem. This is a motion problem. How do I know it's a motion problem? Because when you read it, you see things are moving, all right? So when I see a motion problem, I go ahead and say R times T equals D, right? And then I'll do my little table here. And then I'm going to read a little bit more. A space shuttle maneuvers so that it may capture an already orbiting satellite that is 6,000 kilometers ahead. If the satellite is moving at 27,000 kilometers per hour and the shuttle is moving at 29,500 kilometers per hour, how long will it take the shuttle to reach the satellite? All right. Good stuff. So I know that we're talking about two things here. We're talking about the shuttle, right? The space shuttle. And then we're talking about the satellite. All right, so this creates two different kind of scenario situations. All right, let's see. Now I'm filling this in. Now rate, that is speed. Well, how fast are they moving? Well, it says the satellite's moving at 27,000 kilometers. So 27,000, that's kilometers per hour, right? Per hour. Then it tells me the shuttle's moving at 29,500 kilometers per hour. All right. How long will it take the shuttle to reach the satellite? So time, we don't know the time. I don't know how long it's going to take. All right, I don't know how long it's going to take. Now, every time when people do this problem, these types of problems, they always want to fill in this distance right here. But remember, rate times time is equal to distance. So what I'm saying is 29,500 times x is, I don't want to try to make some distance out of it. I'm just multiplying those and saying 29,500x. Same thing for this one, 27,000x. All right, now we have our table filled out. And now we need to create. So create equation, and it needs to be based off of distance. Based off distance. All right, because that's what we're multiplying it. We want to create an equation based off distance. So let's read this again and think about a focus on distance. All right. A space shuttle maneuvers so that it may capture an already orbiting satellite that is 6,000 kilometers ahead. If the satellite is moving at this speed and the shuttle is moving at this speed, how long will it take the shuttle to reach the satellite? So if we want to create an equation based off distance, right, I'm trying to set the one distance equal to another distance. So I know that these two represent distance, right? The distance, this is the shuttle's distance, and this is the satellite's distance. And at this point, right, if I say, the shuttle, does the shuttle Is the shuttle's distance equal to the satellite's distance? Well, no, because the shuttle is trying to catch up to the satellite. So right now, they are not equal, right? If they were, they would be in the same spot. But the satellite is ahead, right? The satellite is 6,000 kilometers ahead. So a lot of times people are going to say, oh, you just got a plus 6,000 over here, and now they're equal. But let's think about this. The satellite is already ahead of the shuttle. So if I add 6,000, it's going to be even more ahead, and I want it to be equal. So it's not going to be adding here. There's two different ways to do it. You can either subtract 6,000, right? Since it's ahead, if it's 6,000 kilometers ahead and you take 6,000 kilometers away from it, then they'll be in the same spot. All right. But you could say the shuttle plus 6,000, right? Because then if you take the shuttle and you add 6,000 kilometers to it, then it'll be in the same spot as the satellite. And that's usually how I go. I prefer adding to subtracting, but it don't really matter. So now we're talking about the shuttle's distance, right? This is a distance, right? And this is distance. So if I take wherever the shuttle is and I add 6,000 to it, it's going to be where the satellite is. So now I think about this distance, and the shuttle's distance, which we said a minute ago, was 29,500 x. If I add 6,000 to it, then it's going to equal the shuttle's distance, which is 27,000 x. All right, and now we can solve for x. So we built an equation, and it was based off of the distance. So now we can solve for x. So I'm just going to subtract 29,500 x, subtract 29,500 x from both sides. So I got 27,000, subtract 29,500. Then I got, this is 2,500x. This is negative 2,500x, and we're talking about 6,000, right? All right. And then I want to get that x by itself, so I divide by 2,500, negative 2,500, negative 2,500. All right, 6,000 divided by negative 2,500, and I got negative 2.4, and we're talking about x. All right, now x is negative 2.4. Now sometimes when you're doing these problems, you got to think about real life. Usually, that's how you want to think about an application problem, because it's talking about you applying math in real life. Now x equals negative 2.4. Well, what does x represent? X represents time, right? X represents time. So negative 2.4 what? Well, we've been talking about hours, right? So this is negative 2.4 hours. So 2.4, you cannot, here. So we know that time can't be negative first. So x equals 2.4 and then hours. Well, if someone said, well, how long is it going to take to catch up? I mean, you might say 2.4 hours. You could say, the 0.4, you can say 2 hours. And then what's 0.4 of an hour? Well, 0.4 of 60, right? 60 minutes is 24 minutes. Depending on how it wants to, I'd say in 2 hours and 25 minutes, right? If the shuttle's going at this speed, and the satellite's moving at this speed, and the satellite is further ahead, right? The satellite is 6,000 kilometers ahead of the shuttle. Then after 2 hours and 24 minutes, the shuttle will catch up to the satellite, right? Be careful with your equation. Everybody says, oh, well, the satellite's ahead, so it's going to get 6,000, right? But that doesn't make things equal. We want to make things equal. And when we subtract that 6,000, from the satellite, or we add the 6,000 to the shuttle, now they're equal, because it told us in the problem the satellite was already 6,000 kilometers ahead of the shuttle. So if I add 6,000 kilometers to the shuttle's, placement, then they'll be equal, right? So the answer is 2 hours, 24 minutes. That's how long it takes to catch up. But hopefully that makes sense to you. Let's do another. There's different types of word problems. This is a mixture. Let's see if we got. All right, I'm gonna make one up for you, or I'll get one off of your homework. Coming soon. Hold on. Almost there. All right, it says, could have swore I had more of them. Okay, I'm gonna scribble this out. And this one says, two cars are driving in the same direction from the same place. One is man, this is just like that one, so let's not do that one. Two friends live 3 miles apart along the same road. Okay, I like this one. If they walk, so two friends live 3 miles apart on the same road. If they walk toward each other at rates that differ by 1/2 a mile and meet 24 minutes later, how fast is each person walking? Okay, let's think about this. So they live two friends, right? They live 3 miles apart. So if their speed differs by 1/2 a mile per hour. So they live 3 hours apart and they're walking towards one another. Basically, they're like, hey, you start walking my way, I'll start walking your way, right? And their speed differs by 1/2 a mile per hour. And then it says they meet after 24 minutes, right? And it says find their speed. All right. So let's talk about finding their speed. Let's see if I can write a little bit more precise. Okay. So they live 3 miles apart. They start walking towards each other. Find their speed, right? And if their speed differs by 24 minutes. Now, first thing I noticed looking at this, we have minutes and we have hours. That's a dangerous thing, right? If you don't really want to get in the sense of two different units of time. So that's something to think about when we're doing this. But I do see that this is a motion problem, right? And all motion problems. Now, I'm not saying there's, everybody has their own way that they like do things, but I prefer to handle all my motion problems because if I put them all in this same type of format, most of the time I'm successful with them. So rate times time equals distance, all right? We know we got two friends. I don't know their names, we'll call them. We'll just make up some names for them. They're good friends. They're best friends, matter of fact. They're walking 3 miles to see each other. All right, I'm going to just call one of them Tim, T for Tim. The other one, P, I don't know, Paul. I don't know, whatever you want to call it. All right, two friends, all right? The rate. Now, what is their speed? How fast are they going? I don't know. But I know that one friend is going 1/2 a mile per hour faster. So let's say Tim's walking X speed. I don't know how fast he's going. But let's say Paul, he's a little bit more in shape and he's walking a little bit faster. X plus 1/2. All right. Now time. Well, how long did it take for them to get to each other? Well, we know it took 24 minutes. But we also know that we need to be thinking about, we need to be thinking about hours. So we can say 24 over 60 to convert it to hours. 24 over 60, that's 24 divided by 60, which is 0.4. Yep, we just did one like that, 0.4. So this is 0.4 hours. Since we're talking about miles per hour, we should keep everything, unless you want to convert it to miles per minute, right? So we're talking about 0.4 hours. And then what is their distance, right? Well, this is what I'm filling out. Remember, rate times time equals distance. So this is 0.4x. And this is 0.4 times x plus 1/2. All right. So now let's think up an equation that have to do with have to do with distance. So we need an equation for distance. Right? I want to make some equation. Most of the time people try to just take this and say, okay, I'm going to set one equal to the other. 0.4 times x plus 1/2. Now, are their distances equal? Well, no. Why not? Well, because they're not in the same spot. Their distances are not equal. Yeah, they both live 3 miles apart from each other, but one person's walking faster. So if I just freeze them, are they going to be in the same spot, the same distance away from each other? No, one person's going to be a little bit more ahead because he's faster. So instead of just taking them and setting them equal, let's think about it a little bit more, right? Well, how far have they walked? Well, they live 3 miles apart. So how far have they walked? Well, I don't know. But I do know that if I add the distances they walk together, when they meet each other, right? When they meet each other, that will have totaled 3 miles, because we know that they live 3 miles apart. And if I add one person's walking distance to the other person's walking distance when they meet, then that must be 3 miles. So that's what we're about to do. So 0.4x plus 0.4 times x plus 1/2 equals 3. And now we just simplify this a little further. So we got, distribute, and I got 0.4x plus 0.4x plus 0.2. That's 0.8. Yep, that's 0.8x plus 0.2 equals 3. Subtract the 0.2 on both sides, right? So that's 2.8x divided by 0.8, right? I want to get x by itself. I got x equals, and remember, x represents their speed that they walk. So we know we're talking about miles per hour, and it says 3.5 miles. X is 3.5 miles per hour. So I'm going to just say Tim's speed equals 3.5 miles per hour. Whereas Paul, he's the faster friend, speed equals 4 miles per hour. Bam. So they going to meet after 24 minutes. All right, I hope this was helpful to you.